This is the official welcome slide for our remote control of ventilators and infusion pump demonstration today in support of disaster care. This is work that has been going on since contracts were awarded in May of 2021. So this is a demonstration that is from work that's only 7 months old. Next slide. And I will add, as the slide changes, that this is an interim demonstration. So we foresee that there will be other demonstrations in the future, and this is really a capability demonstration of technology, and there are many more pieces to this puzzle that will come afterward. Our agenda today is in 5 parts. We are going to start with some background on medical device interoperability research and the 20 years of investments that have led to the remote control capabilities you will see today. We have 6 scenarios that we're going to demonstrate, and each of those will have an overview slide where the scenario is explained, followed by the live demo. After that, we will have a summary of the capabilities, and we'll talk through next steps and research needs, and then follow up with the Q&A there at the end. With that, I would like to introduce our host for today's demonstration. Colonel Jeremy Pamplin currently serves as the director and has previously served as the deputy director of the Army's Telemedicine and Advanced Technology Research Center. Prior to this assignment, he began the Army's first telecritical care service at Madigan Army Medical Center, and he has served as medical director of surgical and medical ICUs since completing his critical care medicine fellowship at Walter Reed Army Medical Center. Colonel Pamplin deployed twice, serving as the Chief of Critical Care for the 86th Combat Support Hospital in Iraq, and as the Deputy Deployed Medical Director of the 33rd Field Hospital in Afghanistan. He has served as the Principal Investigator for virtual support projects and worked on other major research efforts supporting remote critical care using telemedicine. With this rich background in critical care and telemedicine, it's no surprise that he is hosting this demonstration of new remote control capability for medical devices for us today. Colonel Pamplin, thank you for bringing us together, and over to you.
All right, so again, thank you, Alice, for that very kind introduction. I'm just going to steal a few moments of time from everyone just to give a little bit of background as to what today is really all about. And how we got to where we are. Before I start, I don't know, it's hard to see all the names that are currently in the group, but I tried to scan as best as I could, and I noticed a few of our very distinguished visitors, to include the Honorable Jim Peake. Thank you, sir, for joining us today. I'm not sure if General Place or General Talley were able to join. But if you have joined, or if you have representatives on the line, I'd like to thank you for coming as well. Certainly thank you also for the years of mentorship support that you have given not only to me, but to now really this overall effort. We really would not be here today if it were not for first General Place getting me started down this pathway, and then General Talley believing in Tatrick and the team, to bring the technology and disaster environments or TIDE portfolio forward as part of our COVID acceleration efforts. Really also of great thanks, you saw in the very first slide 3 key logos being Tatrick, ASPR, as well as the Society of Critical Care Medicine. And I think it's important to just, again, thank our colleagues that are both at ASPR and SCCM for believing in this overall effort, and lending their support kind of through the entire journey. We would certainly not be here if it weren't for either Dr. Cadillac, who was at the time of the start of the coronavirus pandemic, the Assistant Secretary for Preparedness and Response, and we certainly wouldn't have been able to get as far as we have without the support for then SCCM President Lou Kaplan, Dave Martin, who's the SCCM CEO, as well as a variety of SCCM clinical leadership who have helped us along the way for now well over a year and a half, really from the very beginning. So really thank you to all of those individuals for engaging in this project, and believing that it can be done. I mentioned the technology and disaster environments kind of portfolio of work. That this component that you are seeing today is only one aspect of Tide that is important, and that is a part of the overall ecosystem of digital health support that we've imagined being able to deliver during really not just disaster, but for disaster preparedness, and really as a platform for potentially changing how we utilize healthcare resources across the United States during even everyday clinical care. The National Emergency Telecritical Care Network was really the first out of the chute, the first of our 3 lines of effort that are within the Tide portfolio. And that capability has now been deployed really across the nation, mostly for our Delta wave surge, but now starting to pick up pace again with our Omicron surge, or anticipated Omicron surge. And it's designed to deliver expertise to the point of need wherever it may be needed. And as you can see, I guess, from the map that's on the screen now, thanks for advancing the slide, there are many parts of our country that are without critical care expertise, without critical care beds. And that expertise ranges from both doctors to nurses to respiratory therapists. And the virtualized hospital line of effort, so Netson being the first line of effort, virtualized hospital being the second line of effort within the Tide portfolio, has really been about enabling clinicians, wherever they may be, to use the tools that are necessary for critical care providers, clinicians, not just physicians, but the critical care team to do the work that they need to do. And most people would imagine that, ventilators are really important. We had a push for maximizing ventilator production early in this pandemic. But, the ventilator hardware is not the problem, by and large. You can always ramp up production for those types of things. The hard part is delivering the expertise to the location in order to use them to their maximal or even minimum effectiveness sometimes. The problem with, of course, using ventilators is that to be compliant with a ventilator, oftentimes patients need medications, and usually those medications come in the form of IV medications, and therefore you need the support of an IV pump that can be adjusted in order to ensure that the patient is appropriately synchronous, appropriately compliant with the therapy that you're providing with the ventilator. Obviously, these two tools can be then used for many other circumstances. And going along with ventilators and IV pumps, in order to do that safely, you have to be able to monitor the patient. So there's a component of remote monitoring that is more accustomed within the world of telemedicine, and certainly within the world of telecritical care. So, the monitoring part may not be quite as novel, but it is certainly important for the remote expert to be able to activate the monitor, to be able to zoom into the monitor, to be able to understand and see the monitors. And monitoring, of course, is not just vital signs. It's being able to see the patient, being able to understand the waveforms on the ventilator. It's kind of the entire ICU in a virtualized box. And that is what we are starting to really demonstrate for the first time, I think, in a more comprehensive continuum of care use case of scenarios today. I think this is not, this is, as I think Alice has already mentioned, you'll probably hear more than once today, this is interim work. Alice mentioned that the work that you're seeing today began really only 7 months ago. That really did begun much longer than that. She also mentioned 20 years of investment. That's also true. But this particular project did begin this summer as part of the overall Tide ecosystem of work, and it will eventually be connected in with the National Emergency Telecritical Care efforts. And then I didn't mention the last phase of all this, which is really collecting all the data and making sense of it so we can better apply resources and capabilities where it is most needed across the nation. So that's our data decisions lines of effort. The magic has really been, however, in the ecosystem. Bringing the DIAC teams on board with a team that was already stroking hard and moving forward in order to deliver capability, the Netson performers, has been, kind of magic to watch. And the magic of the Tide Netson ecosystem has really been the team of teams approach and the inclusiveness, collaboration, sharing that has gone on across the network, and the willingness to solve problems together And by going forward together, we're able to go, in this case, not only fast, but far. So what you'll see today was the gauntlet that I threw down, about not even 6 months ago now, that says, I know you guys all have these statements of work that say we're going to try to deliver something at the end of the period of performance sometime next year. Well, we want to do it faster. We need an interim product, something that you can do and maybe use for the nation if needed very, very rapidly. What's the fastest you can do that? And the team said, okay, maybe October. And obviously that slipped a little bit to the right. But I don't really mind slippage to the right as long as we're getting after it as quickly as we can. And that October date shifted to now the second week of December. And it's still amazing to watch and amazing to see that we are where we are today because of a pandemic. I don't think we would be here today if it had not been for the vision of General Talley, the vision of Dr. Cadillac, the hard work of the Tatric team, the ASPR team, the SCCM team, all the nets and performers, and now all of our DIAC and TIDE and data to decision performers that are helping us to really knock down barriers and move forward in a way that we've not done in the last 20 years. Julian may comment on this, Dr. Goldman may comment on this a little bit later today, or somebody probably will, that a very similar kind of concept was demonstrated during the Ebola crisis, or Ebola, I guess crisis is a good term for it. This is very similar, not quite the same. The scale of what we're talking about today and the capabilities that we're showing today, I think, is much more advanced and much more palatable than it was even back then. So I will leave us with this last comment, and I think this may be one of the hardest things for our nation and our healthcare system to try to wrap their heads around as we watch what we are looking at today. If we are successful, and Matt should have a smile on his face, and if General Talley, you're out there, you'll have a smile on your face as well. But if we're successful with this overall endeavor to deliver remote expertise to wherever it needs to be using, simple tools like mobile cellular devices, and we're able to attach to that interaction, that communication base, that a communication platform, that communication dyad, the ability to execute treatments. In this case, the first use case right now, we're talking about ventilators and IV pumps. You saw we'll maybe doing a little bit of ultrasound today as well for diagnostic tools, monitoring. If we're able to connect all that together in such a way that you don't need an expert to be physically present at the bedside in order to optimize the care of an individual patient. Ultimately, what we do is in the military change what we call the force structure, the way that we actually deploy the human capital to manage a problem set. And I think that's what we're also ideally targeting as we move forward with these capabilities use in our disaster environment. Not necessarily having to deploy a team of 30, 100 humans in order to manage a crisis, but taking advantage of all the humans that are available at the site of the problem using these digital and other technologies that you're seeing today, remote control in the future, maybe even automation of some of this. But the ability for us to bring all that together into the use case you'll see today is really what this journey is all about, such that we can maximize the care, optimize the care of a patient wherever they might be, no matter who is at their bedside. And obviously that's important for our nation. It's also important for our warfighters so that we can bring, America's sons and daughters home from, large-scale combat operations or wartime in the future. So thank you, Julian, Matt. Sorry, I probably took a little bit longer than that you wanted me to. I have one more note here. I just wanted to also thank, there's others that are within our system that aren't necessarily paid performers, but are certainly a part of this journey. Our friends at the FDA, our friends at HRSA, really our friends across the federal government. We have folks that are in CDC as well, BARDA, NIH, that have also kind of joined this overall discussion, conversation about how to make this better. We have friends certainly within the MRDC research community at Combat Casualty Care, MOMRP, and elsewhere. And we really appreciate everyone's engagement and support of trying to kind of bring this concept to the ability to actually use it for patient care. With that, I will again turn it over. I believe it's going to Matt Quinn next, the science director for Tatric, and certainly a well-known name amongst, I think, most of our participants. So again, thank you for joining today. Really looking forward to the amazing work that the teams are going to show us.
So, thank you, Colonel Pamplin. This is Matt Quinn. I'm the science director for Tatric, and I think that Colonel Pamplin covered just about everything that needs to be said. If we can just put up the picture of some of those hospitals. One thing I just wanted to add to this, and is that our National Emergency Telecritical Care Network efforts have so far delivered over 5,000 patient days to 34 hospitals in 14 states and territories. And these are some of those hospitals who have desperately needed critical care support during this pandemic. The one on the top left, Glacier Ridge, always tugs at my heart because it's the size of my kids' middle school. And they had and probably will have more critically ill COVID patients who they can't send where they usually send those patients. They need to care for those patients for an extended period of time. And through NETSN and through the capabilities that we're going to demonstrate today, we will help them do that. The same is true of combat casualty care, where the golden hour might not be possible. We need to extend the ability of our medics and other clinical teams to take care of those patients, those warfighters who are injured much longer. And these are the sorts of technologies that can do that. I'd just like to highlight that, this project is about both what we're doing, but also how we're doing it. The Device Interoperability and Autonomy Coordinating Center, or DIAC, has brought together not just commercial medical device manufacturers, but standards experts, researchers, regulatory agencies, different federal agencies, and many different teams in ways that normally don't happen, to take individual projects and harmonize them into one common project that works through standards, comes to agreement in places where competition doesn't make sense, as well as identifies where it does. The promise here is amazing. And just a few days ago in the National Defense Authorization Act, we received commendation for the development of the NETSN, but also, the urged the military health system to accelerate current and future digital health and telehealth applications throughout the military health system. And we need your involvement and ideas, not just for that, but for incorporation into our broader health system. So excited about this. The real stuff today, I'm going to hand it to Dr. Julian Goldman from Mass General Hospital, who will show you the real stuff here. But I wanted to provide a little bit of context. This is real, and we're excited about it. Thank you.
First of all, thank you, Colonel Pamplin, for providing the overview and the context for the portfolio of work, and to Mr. Quinn for rounding it out. I'm Julian Goldman. I'm an anesthesiologist in Mass General Hospital, and I lead a research program on medical device interoperability and cybersecurity. I'm sitting here in our lab in Cambridge, Massachusetts. We will be connecting from here to multiple other sites as we go through a number of scenarios, explaining in detail the capabilities that have been developed and the implications of those capabilities for clinical work. Give me 1 second as I switch to the camera view. So now you can see. Hello, everyone. There's quite a few of us here in part of our lab in Cambridge. Now, of course, keep in mind, we're running this live with multiple sites, people, cameras. We're expecting a few gotchas along the way, and we'll take a moment and correct those as we go along to ensure that everyone gets to see all the demonstrations. So now I'm going to switch back to the slides and return to the agenda. The first thing that we'll cover is a background of medical device interoperability research investment, which has led to where we are today with remote control capabilities. It won't be comprehensive, but we'll hit the high points. Then we'll go into 6 live demonstrations of remote control of medical devices. As we go through these demonstrations, we will start with a single slide overview for each demonstration. Then we'll go over to the live demonstration, and then we'll move on to the next one in that sequence. We'll then summarize the key things that we saw, and we'll wrap up with next steps, research needs, and a summary. And then we'll open the mic for Q&A as time permits. If time doesn't permit for much Q&A, then as Alice said, all the comments will be captured from the chat, and we plan to either hold another session or disseminate answers at a future date. So let's begin with the background and context. Leading to this point in time, there has been multi-agency foundational research on interoperable medical devices and apps running on open health platforms. And that began around 2004 in earnest. Prior to that, there were projects on some aspects of interoperability and standards, but really things ramped up at that time period. The nature of the research includes technology and systems engineering research, standards development, and a synergistic standards portfolio has been emerging. We'll cover that a bit more in a bit. Also, a regulatory framework for compositional systems has been developed in collaboration with contributors from the FDA. We'll learn more about that, and quite a bit of regulatory science research by many contributors. And there have been proofs of concept and requirements engineering that have been performed through reference platforms, through various prototypes of interoperable systems. We and others have placed a particular focus on the safety of these interoperable systems. And these specifically are systems that are essentially platforms that can communicate with devices, whether they're sensors or actuators, and that use apps. And the modularity and standards-based nature of these systems, as we see today with smartphone platforms, has allowed for tremendous creativity and innovation. Now, if we think about the present, as Matt Quinn said, the National Defense Authorization Act for the upcoming year, so this was just released, points out to the importance of this type of initiative to support future digital health and telehealth applications throughout the military health service. What does the future bring? Well, the capabilities that we will demonstrate today, along with other capabilities yet to evolve, will comprise envisioned smart and autonomous medical systems and advanced telecritical care capabilities. Colonel Pamplin mentioned that in 2014, we and other collaborators prototyped remote control of ventilation and infusion pumps during the Ebola emergency. And a large group assembled, and over the course of a period of around 20 days, quickly cobbled together remote ventilator control. And the drivers for that were anticipated to be that remote control from outside of a patient's room could lead to a more rapid response to urgent patient needs. For example, if the patient's oxygen saturation is low and the patient requires an increase in delivery of oxygen, the problem during something like Ebola, or now with COVID-19, is that there's a finite amount of time required to don the PPE, to put on protective equipment. And that could range from 10 to 20 minutes to be completely geared up and protected. So by permitting remote control from outside of the patient's room, it could not only permit a more rapid response to care for patients, but also reduce the total number of room entries, reduce the PPE consumption, allow for better patient care, and a host of other benefits that you could easily surmise just from those basics. At the time, these capabilities were demonstrated and are publicly available. They were demonstrated multiple times, including at an NSF Smart America Closed Loop Healthcare event, which is available online. Well, fast forward a few years, and the Nihon Kohden Orange Med company realized the value of bringing to market remote ventilator control. And they did that using a dedicated 10-meter remote control cable to allow a connection for this remote graphical user interface to control the ventilator here in the patient's room. This is an FDA-cleared device that was cleared prior to the pandemic. And when we became aware of this at Mass General Hospital, we deployed this system during the pandemic. The things that this introduces, the questions and the safety questions that arise are, is it safe for the device outside of the patient's room to turn off a ventilator inside a room? And the answer is no, not necessarily. And therefore, when you look at the capabilities of this system, the ability to fully turn off a ventilator is not permitted. That requires going to the patient's bedside. And the way the system was designed and marketed requires a line of sight to the patient. So you're right outside the room and you can examine the patient remotely if needed to assess the impact of the changes. Of course, it's pretty challenging to route cables in and out of a patient's room, especially when they're in an airborne infection isolation room. And ideally, you wouldn't require a cable, and ideally, you wouldn't have to have line of sight on the patient, perhaps use a camera. But at the time this was released, this was certainly the most sensible approach in a walk, crawl, run introduction of technology of this type. Well, with the first surge of COVID-19, we started to see photos like this. Equipment moved into the hallway, IV pumps in the hallway with extra long tubing attached. Even ventilators, when and if their display units could be detached, the wiring was kind of stretched as much as could be, and they were put right outside the patient's room. So that was a kludge, in a sense, to just get the job done. But there are shortcomings to having such long IV tubing. There are shortcomings to using equipment like that. And also, for other devices that are in the room, the providers could not hear the alarms of those devices if they're inside the sealed room. And we still had all of the shortcomings that we talked about. But, it just showed the desperation of the healthcare community to do whatever they could during the initial COVID surge, and this still remains the case today. Now, a number of things happened after the declaration of the public health emergency, and a very important series of activities were put in place by the FDA. The FDA released guidance documents. Guidance is something that are routinely released by the FDA, but these were the past guidance that are called immediate in effect guidance that become active without public review so that they could be implemented immediately. And 3 of these are particularly important. One of these permitted remote control of non-invasive remote monitoring devices. The other one relates to remote control of infusion pumps. And the third permitted remote control of ventilators. And by permitted, what that means specifically is that it's permitted without the need for 510K submission. If the manufacturer deems that the changes are safe and are useful during the public health emergency, these could be rolled out right away. So under this immediate in effect guidance, the Medtronic company released a remote control capability for the PB980 critical care ventilator, which is a widely used ventilator. Medtronic developed a firmware upgrade for the PB980 that allowed remote operation using a proprietary tool that they also provided for free called OmniTool. And when these were made available during the first pandemic surge, we tested the capabilities of the system in our lab in preparation for a clinical proof of concept deployment at Mass General Hospital. We evaluated interoperability, cybersecurity, the clinical workflow implications, installation requirements, and we also assessed the role of adding video to replace the line of sight requirement of other systems. The other thing that's become important to bring us to where we are today is the portfolio of interoperability standards that have been developed in a synergistic way. There are quite a few of these. There are some that relate to data communication, standardization of nomenclature, and other aspects that are required for semantic interoperability. And there are 2 that are bordered in red here that are noteworthy for the work that's been done today. One of these on the left is a standard for an architecture for platform-based connectivity of medical devices called ICE, or the Integrated Clinical Environment Architecture. And the other is the remote control standard that was developed within AMI, with a team that worked urgently at the beginning of the pandemic to enable a standard to be available that could be then used in concert with the immediate in effect guidance from the FDA. So with that as the background, let's lay out a bit of what you're going to see today. In today's demonstrations, you'll see live simulations of clinical scenarios in which remote medical device control could improve patient care. The locations include a intensivist from Madigan Army Medical Center located right near that location. Of course, we mentioned the Massachusetts General Hospital and our lab in Cambridge, the Nihon Kohden Orange Med Company in Santa Ana, California, Thornhill Medical in Toronto, Canada, and you'll also see something that doesn't have a physical location, but rather a web-based anywhere application, which is actually going to be shared from Waltham, Massachusetts. The final demonstration, as Colonel Pamplin alluded to, will show remote teleguidance of point-of-care ultrasound. So with that, since you're going to see a lot of people running around, and some of them masked, and you won't know who they are, here they are unmasked, and it's quite a team of contributors working today, and there are others who aren't even shown. The devices that you'll see, and you'll see these icons or these photos in the different workflow depictions. So I want to run through them now to kind of associate them with their capabilities and their companies. On the top left is a transport ventilator, which includes physiological monitoring and oxygen concentrator capability from Thornhill Medical. It's called the Moves SLC. You'll see that, you'll see part of this, you'll especially see the screen, the orange screen. Next over here is the NKV 550 ventilator from Nihon Kohden. Next is the PB 980 ventilator from Medtronic. Next is the Integrated Clinical Environment Platform, the apiary platform from DocBox, and this will have a role in both remote data viewing as well as remote control. You will also see the OmniCure NetSyn virtual telecritical care platform that will be used to identify an available remote intensivist to help with a patient. From our program here at Mass General Hospital, we will be kind of hosting some of the work, some of the demonstrations in a virtual hospital ICU, a virtual field hospital, and we'll also be using open source software that we developed for research purposes, which is also an ICE platform called OpenICE. We will be controlling a Sapphire IV pump from Aton Medical, and the ultrasound demonstration will be performed with the IQ Plus ultrasound from Butterfly Network. Quite a bunch of things. So the demonstrations are early stage demonstrations of technical capability moving towards a fully integrated tied ecosystem, tied again for technology in disaster environments. The 6 different scenarios will include far remote control from the MGH MD-PNP Field Hospital in Cambridge to the NK Community Hospital in California. Now, if you're not familiar with these hospitals, if you've never saw them on TV or in the news or visited them, that's because they're all fictitious. They're all fictitious hospital names and they're simulated patients, but the geographic locations are accurate. So in these demonstrations, we'll really be communicating across North America. Number 2 is far remote control by an intensivist near Madigan Army Medical Center during patient evacuation via ambulance in Toronto. The third is remote control of a ventilator and IV pump here in our lab to optimize care. The fourth is remote control from the MD-PNP Field Hospital observation area. So this simulates control from right outside of a patient's room without room entry. 5 will be a demonstration of a situational awareness dashboard of data from all of the other sites in real time. And number 6 is teleguidance, in which the teleguidance is occurring from Fort Mill, South Carolina, to the ultrasound that will be performed in real time in our lab here in Cambridge. With that, let's get started with the first simulation. So this is a simulation of far remote control of controlling the NKV 550 ventilator as we discussed. This on the left is a picture of the hospital, the NK Community Hospital in Santa Ana, California, and we'll go live to there in just a moment. In that hospital is the ventilator, the patient simulator, and a DocBox IoT ICE platform that will connect the ventilator to here, to the remote MGH-MD in Cambridge. And by the way, we'll all be playing different roles and without actually changing hats, so hopefully it'll be easy to follow along. All right, with that, we're going to switch to the NK hospital, and let's get started. Let's start the simulation.
Hi, Dr. Goldman. This is Miran from the Nihon Koden Community Hospital.
Hi, Miran. How are you today? What's up?
Doing well. We've got a patient here on spontaneous mode who's having trouble breathing on his own, and his O2 saturation levels have gone down. And our respiratory therapist is currently assisting other patients, and I was wondering if you could help us.
Miran, sorry to hear that. And I'm happy to say that we're available. I'm here, and next to me is a respiratory therapist, Alyssa. And if you press the button that allows us remote access to your ventilator, we'll take a look at the data and see how we might be able to help.
I will do that right away.
All right.
Done.
All right. Thank you. Well, let's see. We have to now connect to your ventilator. So let's navigate through our user interface.
All right. So this is at the NK Community Hospital, correct?
That is
Miran,
correct.
is that the location? Okay. Thank you.
Great. All right. I'm going to launch the doc box next to your patient there, so I can see the doc box. Just give it 1 second. It may take a second to load.
Sounds good.
All right. Is your patient Fernando Powell?
That is correct.
Great. I'm going to switch over to the ventilator screen.
Now let's look at the ventilator. It looks to over here, just looking remotely, that the waveforms are flat. Looks like the patient is not making any efforts to breathe spontaneously, and the ventilator isn't breathing for the patient either because it's expecting the patient to breathe. So that means we'll have to change the ventilator mode to something that breathes for the patient. So let's take a look at what we can do from here.
All right, you'll see on the DocBox system, we have that apnea alarm, like there is on the ventilator at Nihon Koden. And we also have those flat waveforms that we see on the ventilator.
All right, let's change to a mandatory ventilation mode.
All right, I'll come down here to the vent modes. Here are the available vent modes to me.
Like AC, VC with volume control.
Great, I'll select and then save.
Good.
And in a second, we should see the waveforms populate and the alarm turn on.
Looks to us like the ventilator has been activated and is breathing for the patient, Miran. Is that true?
It is correct, and the patient is doing better.
Excellent. And when we look at our local screen, actually the waveforms look a little different on our local screen versus yours at the bedside. Alyssa, is this typical when you're controlling something from remotely, or what's going on with those waveforms?
Yeah, so this is really just an interim version of the software. So the waveforms are not quite accurate or precise, but we are still developing this software. So in future iterations, we will see more accurate waveforms.
Okay, well, it looks from here like the patient's doing okay. Miran, is everything all right at this point?
He seems to be doing all right. I'll keep an eye on the O2 saturation.
Okay, well, we'll still be here, and if you need more help, please don't hesitate to contact us, okay?
Will do. Thank you so much.
End simulation. Okay, so that's the first simulation that we just covered. Now we'll go to the next simulation. This one is a far remote control during evacuation of a patient. And in this case, an intensivist will be consulted. An intensivist from Madigan Army Medical Center in Seattle will be consulted to help with the patient that you see on the right, who's on a litter attached to the Moves SLC ventilator and also connected to a DocBox ICE platform. With that, we're going to go live to the remote site and start the simulation. Go right ahead.
Hi, I'm Stephen Dane. I'm an EMT at Thornhill Medical in Toronto, Ontario, Canada. There was a tornado that ripped through the countryside just north of Toronto with a large number of casualties. Our ICUs are full, and we're just loading a patient into an ambulance to transport to the airport. All of a sudden, the patient's blood oxygen levels, or SpO2, are dropping. I need some expert help. I'm going to use the Netson Omnicure telemedicine virtual IC critical care application to call for help. And you can see the application somewhat on my screen there. I'm now going to call for help. I see that Dr. Colombo is available on my application. I'm going to call him right now.
You're muted.
We can see that.
Dr. Colombo, we don't hear your audio.
Hello? Dr.
Hi
Colombo?
there. Can you hear me? Yep. So you can see now, I can see Dr. Dane. This is Dr. Colombo, the critical care doc outside of Madigan Medical Center. You can see on my video teleconferencing app through Omnicare, I can see Dr. Dane. I'm going to go ahead and mute it so we don't get feedback from audio. So on the Omnicare app, we can communicate via video teleconference or audio if we have reduced bandwidth. We can also send each other text messages, clinical practice guidelines via PDF documents, take photos, videos, and send those back and forth in order to provide two-way communication for synchronous or asynchronous telecritical care. I'm going to go ahead and put this down. A feature of the app, not a bug, that prevents us from sharing that video for this demo is that it is HIPAA encrypted and cyber secure compliant. So we will be sharing our audio and video through Teams and Zoom as we have been, but we would normally be communicating through the app. Dr. Dane, this is Dr. Colombo, critical care Netson. How can I help you?
I have a 70-year-old woman here on a Thornhill Medical Moves SLC integrated life support system that also has a concentrator, oxygen concentrator built into it. The patient's blood oxygen level has dropped to till 77%, and I need some help. I'm not familiar with this device. It's now 74%. Wondering if you could give us a hand in responding to the situation.
Absolutely. I see that SAT dropping in the consult on the Omnicure app. Are you able to make the changes on the ventilator if I can make suggestions, or would you like me to make the changes for you?
Yeah, I'm not familiar with this device. It's not one I normally use. If you could make the changes, that would be great.
No worries. So I'm going to go ahead, folks, and share my screen. So you can see I've already logged into the DocBox environment. You can see us. So Dr. Dan, I just want to verify that this is patient Heather 6, date of birth 13 November 1951.
That's correct.
Okay. So I am going to, after I verified the patient, I'm going to go into my apps and choose ventilator. And I can see that the FiO2 is at 30%. I'm going to go ahead and increase that to max for you. If you can just verify I've made that change, just verify that that's occurred.
Yeah, I can see that on the screen there, and I've got it on the pointer.
Okay, so that may take a minute, but we'll just watch those stats with you. Thank you for
75%.
putting the camera back on the vent. I see 75. We may have to readjust that probe. Is it in a good place?
Yep.
Okay,
Good.
so if that's reading accurately, that's not responding fast enough. I'm going to go ahead and make a second change. So I'm going to open up the positive end expiratory pressure for you. It's set at 5. I'm going to turn that up to 10 to see if we can't open up a little bit more lung. So I've made that change. Can you verify?
Yes, I can see that on our monitor here.
Okay, and I will stay
10
with you.
centimeters of water.
Excellent. We'll watch that SAT. Again, if we need to readjust that probe. I see we're in the 90s now. Is that what you're reading? I'm reading on my app.
Yes, I'm getting 91, 89. We're winning.
Okay, we had a transient response there. So we will stick with you and continue to make adjustments.
Okay, thank you very much.
Okay, and I will send you documentation of that in the app and a summary of the recommendations we have and what we've done today. And we're here. Oh,
Okay.
I see we're above 90 again. We'll stick with you. We'll be available as you need us.
Thank you very much.
Okay,
Have a good day.
end simulation. Thank you very much. From Toronto and from Seattle. All right, so this is the simulation that you just saw, remote control during evacuation of the patient. Now we're going to go to the next simulation. In this simulation, we have a patient in the MD-PNP ICU. Okay, we need to stop sharing. There we go. We have a patient at the MD-PNP ICU, and you'll see the devices include a Sapphire infusion pump, Medtronic PB980 ventilator, and a Philips bedside patient monitor set up here with a mannequin. And you'll see these in some more detail as the bedside nurse, Dave Arney, played by Dave Arney today, will show you. And then the remote physician will be able to control the ventilator using the PB980 remote control software and the infusion pump remote control and vital signs display software using OpenIce. So with that, we're going to switch over now to the camera view, and we'll begin with the bedside nurse, Dave Arney. Begin simulation.
Hello and greetings from the MD-PNP ICU. I'm going to walk through the equipment setup a little bit before we actually start the simulation. So here we have our patient on the bed, our patient Rodney. Rodney is connected to a Cpam Medical Sapphire infusion pump receiving norepinephrine, a Medtronic PB980 ventilator, and a Philips MX800 patient monitor. The ventilator is connected to a lung simulator, which is hidden behind it, and the patient monitor is connected to a Fluke electronic patient simulator, which is creating the vital signs that we see on the screen. These devices are connected through two parallel systems. All of the devices are connected to our OpenIce research interoperability platform, and the ventilator is also connected to a Medtronic remote control software for non-clinical use here in the lab. So, having set the stage, we'll now start our scenario. So I am the nurse in this room. I'm not very familiar with this particular ventilator or how to change it or how to help this patient, but I know that their oxygen saturation is low and that their blood pressure isn't great either. So I'm going to call for a remote teleconsultation and ask for some help.
Hi, this is Dr. Lee from the Tele-ICU consult service. I'm joined by my RTE here. How can we help today?
I've got a 48-year-old male patient who's on a ventilator on pressure support. Their oxygen saturation is not great. It's at 84, and their blood pressure is also a little bit low. I'm not very familiar with this ventilator, and all of our RTs are busy with other patients, so I need a little help to do here.
Happy to help. Is it possible for you to give us access to your monitoring capabilities?
Yes, please go ahead.
On my screen here now, I can see that we have access to all the ventilator monitoring, vital signs, and also your infusion pumps. It looks like we should increase your PEEP from 5 to 10. I know your RT is busy. Is it okay if we control it from our end?
Yes, please.
Okay. Yi, are you able to change the PEEP from 5 to 10, please?
Yes.
And let's send the command when it's ready.
The PIP currently is set as 5.
Yes, and let's increase it to 10.
Let's change that to 10. I will send it the control.
Perfect. How are you doing over there, Nurse Arnie?
Yes, I see that the PEEP has changed on the ventilator, and I even see the change in the waveform.
Perfect. How's the patient doing?
Their saturation is going up a little bit, but I noticed that their blood pressure is also starting to drop.
Yeah, it looks like the blood pressure is dropping. We can see that on our end as well. I think that your current infusion rate for the norepi is at 15. I think we should increase it to 30. Would it be okay for us to change it on our end?
Yes, please go ahead.
Okay, let's increase from 15 milliliters an hour to 30, and let's send the command.
Okay, the command is sent.
Okay, I'm checking back in. How are you guys doing?
Let's see. I'm watching. I see that the pump has changed its rate and is now running at 30. And I'm looking at the blood pressure, and I see that the blood pressure is already starting to come back up.
Perfect. Please let us know if you need anything else. We're on standby to help at any point.
Okay, great. Thank you very much.
End simulation. Okay, so now we're going to go to our next simulation. And in this simulation, we are going to show remote control from the observation area right outside of the MD-PNP Field Hospital. And so, hello, this is the MD-PNP Field Hospital, as you can see. And Moses is going to point out the beds that are here. There you go, Moses. So that's show us bed number 1. Yep, number 2 and number 3. And as you notice, each of these patients or simulators are connected to different ventilators, 3 different brands of ventilators, different monitors, and the data from all of those are being acquired and transmitted, as you'll see in the next scenario. But in this scenario, we're focusing on the physician working with the respiratory therapist in the observation area. So let's switch cameras to them. Dr. Lee, please proceed.
Looking at the patient and looking at the waveforms, I think we should increase the respiratory rate from 10 to 24, please.
All right, I'm changing the respiratory rate now. You can see the waveforms have changed.
All right. So there's a close-up of the ventilator, and you can see the change there, right there in the ventilatory rate that was driven right outside of the patient's room from the observation area. So that's a fairly, this was a very brief simulation intended to show the scenario that we discussed before, in which hospitals are finding ways to control devices from directly outside the patient room. Really, of course, if the technology is there, it doesn't matter where you are, but it does matter from a risk management standpoint in terms of being aware of the full patient context and whether it's safe to make those changes or not. All right, so that was that simulation. And I just want to reiterate that in the field hospital, there are 3 different ventilators and different patient monitors. And as you'll see here in the next slide, which sets up our next simulation, we're going to look at something called the Cpam Dashboard, the cross-platform application module dashboard. The Cpam Dashboard is also part of the virtual hospital and Netson work, and it taps into the data, the standards-based data coming from all of the different systems. So we have 1 patient at Thornhill Transport in Canada, 1 patient at NK Community Hospital in Santa Ana, 3 patients at the MD-PNP Field Hospital, and 3 patients in the MD-PNP ICU. And with that, we're going to switch over to see the screen of the Cpam dashboard, and this is being driven out of DocBox in Waltham, Massachusetts. So now, sorry. Okay, there we go, and now you're sharing your screen. Please begin simulation.
Great, thank you. So we're working from the Netson Command Center, and this is the combination of DocBox's open health platform with real-time data aggregation and the Netson Central Integration by Expression Network. So what you can see on here is at the top the sites that you have available, as well as capacity numbers and bed numbers as they go forward. And also what's available for these. Currently, these are metrics that are reported daily into the Netson. You can also see the sites and locations of where this is coming from. As you've seen from these demonstrations, we are controlling devices from Massachusetts to Orange County and from Washington State to Toronto. So that was the hospital sites that you see that's available. Part of this also is actually looking at what is the health of those clinical locations and what's going on with them. And as you can see here across tiers, we're looking at different factors and different variables to make that determination of what the health of the status is. And you can see right now that the MD-PNP Field Hospital has got three flowers that are petals that are currently red. And for us to see additional information about this MD-PNP Field Hospital, we would actually just go ahead and make a click onto this. And I'm going to actually just have this already open because it does take a couple seconds to load. And you could actually drill in and actually see more real-time metrics, real-time meaning within the last hour of that current site. So what we have here is 8 active beds, 5 ventilators, 6 multi-parameter monitors that are actually occurring. We're looking at the number of patient admits across per day. And then we're looking at the total ventilation hours for the past 5 days. And so as you can see, yesterday, there was an increase that occurred at the MD PM Field Hospital. And, we're not even fully through the day, and we actually are considering to see more ventilation hours that are occurring. The number of active beds at that site per day. And then at the very bottom of this, you actually can see the number of unique devices that have been utilized for that specific day. So you're seeing an increase in monitor use as well as ventilator use at that MD PMP Field Hospital. And that would be able to give you some additional operational metrics about what's actually happening there, and to continue to drill down and drill in. Parts of the future of this will be actually to be in adding more details around acuity, and potentially even ventilator modes, of which modes are being used at each site for additional information. So that's all. Thank you.
Okay, so thank you very much, Tracy. And so that was the Cpam dashboard. And, the focus now was on the real-time operational data and the fact that everyone could see when ventilators have come online or offline, to then decide whether there are issues that might be occurring around the country. Also, though, we should think about the massive amount of data that this allows access to for research purposes as well as operational and clinical purposes. So now we'll go to the final real-time demonstration. This is a demonstration of teleguidance of point-of-care portable ultrasound and integration with Netson. Now, I can tell you that when I started in medicine, ultrasound was a little bit different. Every image looked like a Rorschach test. And fortunately, things have come a long way. Not only is the image quality better, but we're talking about tiny devices that attach to a smartphone and the ability to transmit images. I think the really profound change that we're looking at now is the ability for the local user to not necessarily be an expert, but to tap into the expertise of perhaps a physician, ultrasonographer, other person who's trained in that. And not only to get that person's knowledge in an image interpretation, but perhaps equally important, figure out which way to point the darn thing and how to aim it, and to set it up correctly. Because for all of us who've used ultrasound, there's quite a steep learning curve. So in this demonstration, we're going to show the Butterfly IQ Plus ultrasound and show some of its native capability, which is the teleguidance. In addition to that, we're going to show additional capability that we developed under this Netson portfolio, which is the access and integration of those images wherever you might need them. So with that, we'll begin the simulation by going to the camera and go right ahead. Oh, and microphone-wise, let me just, I think, move this closer to you. Okay, great. All right, go ahead.
Hi, good afternoon. My name is Rick Mendez. I lead the clinical development at Butterfly Network. I am going to be reaching out via our teleguidance application to Samantha Limepuller, who is in Fort Mill, South Carolina, and is our expert in ultrasound. And so through our teleguidance capabilities, I'm going to pull up Samantha to help me locate some blood vessels in my neck that are critical to find. So, hi, Samantha. I'm really having difficulty with finding my neck vessels. So, and I was wondering if you can just help me.
Absolutely. Okay, so I see that you are in the wrong preset for carotid. You're actually in the abdomen preset. So what I'm going to do is I'm going to change that for you so that we can accurately evaluate the carotid, which now we can see right here in cross-section. And I'm going to actually change your depth just a little bit, just to bring it a little bit more, crispen it up. That's awesome. All right, and one more thing I want to do is I'm going to send you a command to your screen, and I want you to be able to turn on the carotid so that we can see it in longitudinal. So this is going to be an augmented reality overlay that you're going to see, and it's going to show you how to rotate your probe or transducer. That's perfect. That looks great. Okay, so I'm going to go ahead and freeze the image and take an image for you for documentation purposes. And then I'm going to unfreeze. And what I'd also like to do is put on the color Doppler. So I'm going to activate that. That way we can evaluate the blood flow of the carotid. And that looks great. Awesome. Perfect.
Terrific. Thank you so much, Samantha. I'm going to go ahead and end the session and send that image up to the MGH PACS device so that they can review it. So thank you again. At this point, I'm going to send that image that we acquired directly to the MGH PACS for further review.
Okay, thank you, Rick. So now we're sharing the screen on Open Ice, and we're going to navigate on our server located right here using an open source PACS system to the image that was just uploaded to the cloud. We're pulling it back down, and now we're able to select it and view it. And we'll go through that. We'll select. And look at that. Nice.
And awesome.
And then we also can, go ahead, you want to speak through it? We're also going to, we can send those images to any web address as well. And so move them around as needed for others to review, analyze, and help with diagnosis. Okay, that's the end of that simulation. So thank you to those who were in Fort Mill, South Carolina, and thank you, Rick. Okay, we're going to wrap up today with four more slides to summarize what we saw and talk about next steps. And this is good. Okay, so what are the next steps? Well, you saw that although there were quite a few devices shown today, there's certainly a need to add more, and work is underway to add a NeuroWave AccuPump dual-channel IV pump with an interoperable interface. Also to add the Medtronic PB980 remote control to be more fully integrated. We saw a standalone capability today that's still not yet a product. And also Cognitive Medical has a clinical user interface that allows patient management, and that's also being integrated for reading patient and device data remotely and controlling the devices as well. So that will control the NeuroWave pump as well as the Thornhill ventilator. We're also working on prototyping requirements for common user interfaces. What are the minimum levels of control needed? How should that operate? And what does the risk management look like to ensure safe remote control? We're working on additional Netson platform integration. What we saw today is not everything was fully integrated into the Netson platform writ large. And there's analysis and testing to be performed on cybersecurity and risk analysis and mitigation strategies for regulatory submission. The teams have already been engaging with the FDA through the DIAC and will continue to do that regarding the best regulatory approaches for this type of transformative technology. And we hope to have follow-up demonstrations, most likely in the spring of 2022, and in which will show additional capability. A lot of research needs have been identified during this work, if one wishes to move on to clinical deployment. There are many categories of research needs: technical, administrative, and patient safety. We discussed a lot of the technical aspects today. There are also questions about who should have access to remote control. When is it safe? When is it unsafe? How can we determine whether people are qualified to do the work? Another important topic that we started investigating is contention for control from different locations. For example, from the bedside versus a remote location. What happens if people at both locations both want to control the device? What happens if the local provider makes a change and the remote provider makes a change, and maybe it's a more appropriate change by the remote provider, but yet there's a delay in the data transmission over the internet to reach the devices. These are some of the things that we've been investigating and that need to be investigated further. Alarm management is another important topic. Should it be acceptable for the remote providers to silence an alarm? Think about the implication if the bedside provider doesn't know that there was an alarm, that could be unsafe. On the other hand, if there are too many alarms, we know that's unsafe. Of course, the security of medical devices, IT systems, and remote control access points must be addressed. And this is particularly challenging because the nature of medical devices until recently has been that they were not designed from the ground up for security, with few exceptions. And we have to work with the equipment that exists as we see more advanced devices and more secure devices released to the marketplace. We have to consider the device characteristics for safe remote control. For example, the response time of a device. If you think of standing at the street corner and pressing the walk button repeatedly, does that make a difference or not? Does it change any faster? Or what if someone doesn't see a change right away on a remote interface, so they keep clicking and making changes, and they end up with a change that they didn't really want? Data logging is important, and there's a standard under development, actually just completed within AAMI, on data logging for ICE environments. Without a comprehensive data log, quality assurance and analysis is nearly impossible. Well, there are many more topics, but this is an example of the things that the teams are thinking about. So in summary, today we demonstrated core functionality of rich data communication and remote control of medical devices for critical care. We demonstrated multi-vendor, also called heterogeneous, standards-based open health platforms with integration of medical devices and apps. There were apps for remote control, there were apps for data viewing, there were apps for a number of things that we didn't call out necessarily as apps, but that's what they were. And we demonstrated capabilities to enable new clinical and operational care models. We operationalized a new model of public-private collaboration, that is the DIAC, which was stood up expressly for this purpose, to facilitate collaboration. And this has allowed us to develop urgently needed patient care solutions. In summary, as we think about future applications, clearly this applies to civilian disaster response and to operational military medicine, whether large-scale combat operations or multi-domain operations, which result in prolonged field care environments. So with that, we've concluded the presentation of the simulations. I'd like to thank everyone for participating and for working so hard to ensure that we could do this in real time, live, with reasonable level of assurance that it would work. And with that, we're going to first turn over the mic to Colonel Pamplin, and I believe then start to begin the Q&A period. Thank you very much to everyone.
Hey, thanks, Julian. Thanks, team. It was really just I continue to be blown away by the work that you all are doing. I think that we have a few comments in the chat. Also, just recognizing the tremendous work that you've done and the potential that this type of technology, this capability can bring to a broad swath of healthcare. Not just during a pandemic, but during a disaster, really across the globe, maybe even into space, and the potential impacts that we have in training. One of the challenges that I will say that technology development, particularly this type of remote control and telemedicine technology, is kind of the ocean of opportunity. Right, and focusing the capability down into a space that's actually achievable, a use case, a concept, a focus area that is really, really important, I would say, for this type of capability. And just for the audience, we have not specifically said this today, but one of the foci that is allow the teams to move with, I think, a little bit of freedom of maneuver that is away from traditional regulation and traditional, the complexities of healthcare, is the target use case for what we are talking about with disaster response, nets, and remote control of devices. And that use case is when you do not have access to a remote expert. You do not have a respiratory therapist. You do not have a physician, doctor, nurse, whomever it may be that is familiar with, facile with capable of using the devices that you need in order to manage the patient's care. These types of scenarios occur not infrequently in the military. They actually occur not infrequently in the United States and very remote parts of the country, but also during long-range transports potentially. And they actually limit our ability to move patients around this nation on a regular basis. So, focusing this away from the hospital, focusing this away from an intensive care unit use case, focusing this capability away from an ER or an environment where you have some expertise in the technology has actually, I think, allowed the teams a freedom of maneuver that they haven't previously had before. And I think that that target, that goal, will help the overall project move forward. Obviously, this is a little bit of an assumption. There's opportunity for discourse and maybe even some disagreement there, but would be interested in hearing people's opinion about that and helping to move that use case, the initial use case concept forward. With that, I'm going to turn it back over to the team for their Q&A. Again, very impressive, very well done. I don't know how many people online are really, truly appreciative of how difficult this demonstration was, to be able to do all of that in real time, not just from point to point, from point to multi-point in multiple different states, with across multiple different networks of support using essentially the World Wide Web. It's just I've never personally seen anything like that before. So very, very impressive. And thanks all for joining us today. Over to you, Julian, for the question and answer period.
Okay, thank you very much, Colonel Pamplin. I think I'll take a second to remember somewhere around 2010, I think, or maybe 2012, when we sat at the FDA and discussed some of these ideas of remote control. And to many people all over, they wondered, why in the world would you ever need something like that, like remote control? And clearly it isn't safe. And the more that the conversations evolved and became more sophisticated about thinking of that as a capability that could alter and improve clinical workflow, the more it started to make sense. And we really wouldn't be where we are today after, frankly, decades of discussions about interoperability, always tending to look at it in a very limited way. We wouldn't be where we are today without this extensive portfolio of work of the virtual hospital program, Netson and Tide, Medea, and some other TLAs that are really allowing a diverse group to work together towards a common goal very quickly. So I know that I can speak for many of us, perhaps all of us, that are pretty grateful to be part of something that has transformative capability. With that, Alice, are you going to, I guess I should look at the questions.
I can go ahead and feed you a couple here. We'll see how time goes. One is, are these remote capabilities, these technologies, available today?
Yeah, it's a good question. And I'm just wondering if we should switch to Teams to allow the teams, the performers, to share their screens, or should we stick with this? If you have, Alice, do you think that will work? I don't know how many people are also trying to show their video on Teams.
I have about 10 minutes left, switching.
Yeah, I'll keep it like this for now. So yeah. Some of the capabilities, so we showed capabilities today. Nothing was really, of course, everything was real. We didn't fake anything, but the maturity level of the technologies was quite different across the board. There's availability today of remote data access, remote data viewing. The remote control was really working, but the products are not necessarily on the market because there's more work to be done in those areas, cybersecurity and risk management and so forth. But some of them are and have been. For example, the Nihon Kohden product with the cable-based control is available and is being used to good effect. The Medtronic version of software, which we didn't show today, was available under the guidance that we discussed and in use by hospitals. The Butterfly Network's remote control of the mode of the device setting and is also available. That's an FDA-cleared product. So we're awfully close. But there is substantial work to be done to ensure that these capabilities, it's pretty obvious to everyone that these can be misused, misapplied, and not be implemented safely. Some of that is related to policy, and some of it's related to core technology and its stability. So at this point, I think the direction is clear, the work to be done is clear, And the rest is a matter of focus and resources to bring these capabilities into widespread use in healthcare.
Hey, Julian, this is Matt. I would just add one more piece that's available today and actually being used are the Netson platforms.
Sure. The OmniCure platform. There are others we didn't show. Mm-hmm.
Correct.
Yep.
Yes.
Yep.
That
Excellent
is
point.
being used to deliver telecritical care today.
To almost 5,000 patient days to this point. Alice, next one, make it easy.
Okay. Well, I don't know how easy this one might be, but there's a question about how interstate medical consults could be handled in these situations, or how they are handled.
Yeah, that's an interesting challenge, and I think that let's bring in one of the team members who's been dealing with this directly, Colonel Colombo. Dr. Colombo, if you're on the line, could you take that?
Yeah, Julian, I certainly can. So that's actually one of the things that we've struggled most with, particularly with Netson. We have found that the myriad patchwork, different regulations per state, and the different responses of state governors and governments to allow blanket permission for telemedicine consultation across state lines. Some will require an expedited emergency license. Some simply do not have an approach because they don't acknowledge that this is feasible. This really kind of brings the call forward for some blanket regulation to allow and control and make safe telemedicine across state lines from a federal level during a disaster response in particular, which I think would be an appropriate justification to do so, really because it delays care, makes these responses far more complicated and delayed. And really, when you're talking about the ethics of taking care of folks who are with a need for critical care or with a need for expertise and simply do not physically have the option to get it, and we have technology that can provide it rapidly, safely, and competently to intervene and save lives, really the moral and ethical case for creating that regulation and that pathway is absolutely clear to us. But it has been a struggle throughout this entire pandemic. Over.
Thank you. Also, I'd like to add, I think I didn't put enough fine points on my comments before. You know, the notion of availability, we looked at so many things today, some of them potentially high risk, and some of them not high risk. For example, the data dashboards and your point, Matt, about the fact that the Netson applications are already deployed and being used in many hospitals, and the data dashboards that are available through the DocBox implementation and the Cpam are available today. That's another example of rich data that's available. So rich bedside data, bedside documentation, using ICE platforms such as DocBox, those are also available today. We're also showed very far future capabilities that are going to take longer to implement. So let's think about this kind of in smaller Lego blocks that some are more mature and some are less mature. Okay, I just wanted to take a moment for that, and then let's go to the next comment. I didn't know if Sandy or someone else from the FDA had their hand up, and if not, I'm not
happy to weigh in from an FDA perspective, even though I don't speak for the agency, obviously. I think on the phone now you have Heather and myself. Heather's much more from a top-down perspective, and I'm much more of a technology looking up. And I will say we support this activity 100%. I mean, the FDA has been and is trying to promote interoperability to get devices to talk to each other so that we can have this app-based platform. And as Julian has pointed out, there's lots of safety issues. And this is a spectacular method of eliciting what those safety issues are so that we can address them. Because we need to perform good and robust risk management. I will point out that a lack of this application is very risky because people tend to die when you can't give them adequate care. So when we do risk-benefit analysis, we have to weigh those two things. And I know Colonel Pamplin has pointed that out numerous times. I mean, not having this system is really bad. And we should all move this forward from both a technical societal, regulatory, funding, resource, whatever perspectives we need to marshal, we should get it going. Over.
Thank you, Dr. Weininger. Anyone else? Heather Agler, are you on as well?
I am on. I don't have much of a voice, but I completely agree with everything that Sandy said, and that we really do support it, and we see the benefits of this type of technology. And, we hope that we can, create that regulatory pathway that makes sense. When your options are nothing, or, some risks associated with these devices, like he said, we look at that risk benefit, balance when we take these into consideration. And so we look forward to the progression of this project as it moves forward.
Well, thank you very much for those comments. I see that we're close to the bottom of the hour. So Alice and MITRE crew, Colonel Colombo, anyone else, do you want to wrap things up or take some more questions?
I do have one more question here that that hasn't really been touched on by any of the commentary, and that's one around industry standards and how what has been shown today relates to existing industry standards for the healthcare sector.
It's good. It's a very good question. We have a number of people that can help answer that. And actually, I think Dr. Weininger is a good expert to respond to that.
So I think that we have been developing what we consider to be relevant industry, regulatory, academic partnership standards for the last 2 decades in anticipation, frankly, of this moment. There's still clearly a lot more work to be done, and a lot more participation is needed. And there's standards in other venues, if you will, in clinical applications, clinical practice guidelines. I think, as Dr. Kaneva's pointed out, how do you train the relevant caregivers on the other end for these kinds of operations? So I think we have been in our own small ways trying to move the ball forward. Clearly, there are larger boulders that need to be lifted.
Thank you. And I believe Dr. Dane is on the phone as well. And Dr. Dane is a senior standards expert and physician who chairs several relevant committees. I didn't check to see if you're available, so I don't want to put you on the spot, Stephen.
Can you hear me, Julian?
Yes, we hear you.
There's been a lot of standards work done in this area, both from the equipment point of view. ISO TC 121 anesthesia and respiratory care equipment has developed standards and guidance for inputs and outputs of medical devices from a broad range of equipment. IEEE 1173, going back to the early part of this century, 2004 specifically, has done excellent work on developing domain information models for medical device communication. That's 1173-10201, and for vocabulary, 1173-10101. There's also been a lot of work done for medical laboratory work, LOINC, that we can leverage, and the SNOMED terminology, international version and the country-specific versions are also useful in this area. So there's a lot of standards work being done. There's a lot more to be done. We're now looking at it and filling in the gaps and building on what we have now. Over.
Thank you very much, Dr. Dane. And before I hand it back to you, Alice, for final wrap-up, I just would like to share the slide once again of, again, not everyone who was involved in this. There are others not shown, but this was really a team effort, and I'm grateful to all my colleagues for the effort that they put in and for the results. Look forward to further discussions, follow-up meetings, and a whole lot more good work to do. And with that, Alice, let's hand it back to you.
Thank you, Julian. I just want to remind everyone that we do have a recording of this event. So if you would like to have a link to that recording, please email me at at miter.org. That was shown in the first slide on the of the presentation. With that, I thank you very much for your participation today and celebrating with us this milestone of a new capability for the healthcare community in disaster support, generally speaking. Hope you have a very lovely Friday, and we look forward to seeing you at future demos. Thank you.
Thank you all.